right. Okay, so you should have your first derivative test notes out, please. Okay, so the goal for today, okay, is that we'll take notes for maybe like the first half of class. Second half of class, you'll have time to work on your homework from last time. So we're going to finish up the first derivative test today. Okay, so we already did number 1. We already did number 2. We're going to pick up on number 3. Okay, right here. Okay, from last time. No. Okay, last time I had you skip this one, and the reason why is that what is the first step to the first derivative test? Take the derivative. And if you look at this equation, what rule are you going to need to take this derivative? Product rule is correct. Very good. So we're going to take our derivative. That's step 1. But we're going to need to use product rule. So break down your 2 little pieces here. My u is going to be an x squared minus 3. My v is e to the x. We're going to take the derivative of both of those pieces separately. So what's the derivative of x squared minus 3? Okay, 2x is correct. What about e to the x? E to the x again. Now, let's say that you decided to do chain rule on this. Remember, e to the x is its own derivative, but then what's the derivative of just x by itself? An extra times 1. So remember, you're really always doing chain rule. But if the x is alone, the derivative is just a 1 anyway, so it doesn't change it. Okay, so over here to the side, let's write our derivative. F prime equals. We'll do this diagonal, which is x squared minus 3 times e to the x plus. And then this diagonal is 2x e to the x. Okay. Now, when we talked about product rule, I told you that a lot of times on the AP test, they'll always try to look for a GCF. The reason that they do that is that on your derivative test, after you take the derivative, what do you set it equal to? 0. Very good. And the way that you solve this equation would be to look for a GCF because you're going to factor. Whenever something's equal to 0, you're trying to factor. So taking a look at those 2 terms, what type of factoring could I do? What do they both have? E to the x. Very good. So I'm going to pull my e to the x out. And then from the first term, I'm going to have the x squared minus 3 left over. And then from the second term, I'm taking the e to the x out, but I'm going to still have a 2x left over. And then from there, you should be able to tell that this equation in here, that's a quadratic. Now, it's not in the right order, but I can fix that, right? So if I wanted to factor this, I need to put it where it's ax squared plus bx plus c. So I'm just going to reorder this piece so that it's going to be e to the x, x squared plus 2x, and then minus. Remember, you don't have to change any signs unless you're crossing the e. Okay, so set up your little chart or however you factor. My AC number is going to be 1 times negative 3. And my basement number is a positive 2. What's the only way to times the 3 since it's prime? 1 and 3, very good. And if I want to keep the 2 as a positive, where should I put the minus? One side, very good. So I'm going to have e to the x, x minus 1, and x plus 3. Okay, remember, all along this has been equal to 0. All right, the solutions to this equation are called the what? CN, what does it stand for? Critical numbers, very good. So if I have x minus 1, that means that my critical number is x equals positive 1, because remember you want to change the sign. And then I have an x plus 3. That means my second critical number is going to be x equals negative 3. Now, let's talk about e to the x for a second. And I happen to have just tested my pre-cal kids over this. Okay, but the e to the x graph looks like this. So does it ever equal 0? Okay, it's your exponential growth graph. Remember, it grows from 0, but it doesn't ever actually cross. So why that's important is that e to the x isn't going to give you any extra numbers because it never actually gives you a 0. Okay, so our only two values are 1 and -3. Put them on a number line. So -3, +1. Remember, you do want them to be in order. Okay, from here, you are testing the sign of f prime to tell us what f is doing. And remember, when you plug in, you're plugging into this, okay, inside this box. Now, do I care about the number that I get for each parentheses or just the sign? Just the sign. Very good. So somebody tell me a number bigger than 1. 2, because it's got to be bigger than 1, right? Okay, so say I pick 2. What is 2 plus 3, positive or negative? Put a little plus right here. What about 2 minus 1? So far I have 2 pluses, and then what did we say e to the x is? Always positive as well. So plus, 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 multiply those together, you get a big plus for that interval. Which means that if f prime is positive, regular f would have been uphill. Okay, between -3 and 1, what can we pick? 0 is a great choice. 0 plus 3, how does it come out? Plus or minus? Positive. What about 0 minus 1? Negative. And what about e to the anything? Always positive. So I have plus, minus, plus. Overall, what's the sign? Big negative. Which means that f would have been going downhill because its f prime or its slope came out negative. Okay, one more interval left, less than -3. What can we pick? -4 is great. What's -4 plus 3? -4 minus 1 more? Negative. And e to the anything? Positive. So I have minus, minus, plus. And remember, the negatives undo each other in partners. So if I have 2 negatives, those cross out. Overall, big positive. All right, now for your homework, make sure that you pay attention to what the question's asking. This one isn't asking you for mins and maxes. It's asking you where the graph would be increasing. So if I look at my number line, what intervals are increasing? Okay, here on the left, and then also here on the right. So let's put a little sentence here. F is increasing on the interval from. Now, if this goes all the way to the end of the number line, remember we'll put negative infinity to -3. And then when you do your homework, there is a button for you to pick for union. Don't just put a U. I think it'll kind of wrong if you do that. Okay, and then my second one is from 1 to infinity. Okay, I want you to write because, okay, for the AP test, a lot of times they'll say to tell why, you would say my f prime of x is greater than 0. Okay, my f prime came out to be greater than 0. That means that my graph would be increasing. Okay. Huh? Also, can you label on your number line? You should have a max at -3, and you should have a min at 1. Okay, overall, we kind of remember that? Okay. Go ahead and turn to the next page. So everything that we've been doing, okay, if you want to peek back at number 1 for a second, everything that we've been doing has been finding relative mins and maxes. So I'm going to go back and add that word in. Okay, relative mins and maxes. This is on the graph we kind of sketched for number 1. Here's what that means. A relative max is the biggest in its own little neighborhood. Okay, if I look at, remember, we kind of sketched this on number 1. Is this the biggest point everywhere? No, because eventually what's going to happen? It's going to go up to infinity. So a relative max is just the biggest in one little section of the graph. In the same way, a relative min is the lowest and we call it its own neighborhood. Okay, but eventually this side is going to go below where that is. So if you turn back to the page we were just looking at, we're going to define the difference between a relative max and an absolute max. Okay, a relative or local max is going to be an f of z that is greater than f of x for all of the x's in the neighborhood around c. So a relative max is only the biggest in its own little neighborhood. Now, there can be multiple of those. So if I were to draw a graph, let's say that kind of like goes like this. Okay, then in that case, I could have 2 relative maxes. Okay, however, they have to happen at critical numbers. And the reason why is because in order for me to get that kind of little mountain shape, you have to have a slope change from plus to minus. Okay, but for relative and locals, you can have more than one. Now, jump down here where it says absolute. An absolute maximum is going to be the f of c that's greater than everything else for all of the x's in the domain. And you can only have one of those. There can only be one y value bigger than all the other ones. Okay, so take a look at graph A. Does graph A ever have a like at the top of a hill in it? No. This one does not have a relative max. But it does still have an absolute max because there is still a point that's higher than all the other points. And where would it happen? At B. So even though there's not a relative, there is, I'm going to put yes for an absolute max. Okay, so I don't have a little hill that gives me a relative, but I do still have an absolute winner, and it would be the endpoint. Take a look at graph B. Do I have a relative max? Okay, right here. And then that relative max is also the absolute max. Because not only is it the biggest in its own little area, it also happens to be the biggest for the whole graph. So it's possible for you to have one but not the other. And then it's also possible for them to be right on top of each other. Okay, the one big difference is that your relative mins and maxes have to happen at a slope change. But if it's an absolute max, it could also happen at. So let's come back and fill that in. Absolute maxes can happen at critical numbers, or they can also happen at endpoints. Okay, they can happen at critical numbers or endpoints. So when you're ready, go ahead and turn the page. We're going to skip extreme value theorem, and we're going to go to where you have your little steps here. Yeah. Sure. If you can wait till after notes, that'd be great. But if not, it's okay. Okay. So jump ahead to your steps. Okay, if you want absolute extrema, here are your steps. Step number 1, you're going to take the derivative. Step number 2, you're going to find your critical numbers. Remember, that's where you let your derivative be equal to 0 or undefined. So let's do that part first, because that part is kind of the same. So if I'm taking a look at number 6, I want to take the derivative of that equation. Okay, unfortunately, it looks like we're going to need what rule? Quotient rule. Now remember, if you can avoid quotient rule, you always do it. So what I'm noticing is that I have a bunch of X stuff, but it's not divided by more X stuff. It's just divided by 5. So I can avoid quotient rule if I do the following. Okay, I'm going to rewrite this. And I'm going to let the X to the 5th power be divided by 5. And then I'm going to let the 5X be divided by 5. Okay, why am I doing the rewrite? Because I don't want to do quotient rule if I don't have to. So if all of that is divided by 5, I'm going to separate it. And then I'm going to rewrite this first term. It's going to be a 1/5 X to the 5. And then on that second term, what happens if you have 5X divided by 5X? It's really just an X. Okay. Now notice I haven't taken the derivative yet, but I'm about to. So now that my S is separate terms, no more quotient rule, let's take the derivative. What would the derivative be of 1/5 X to the 5? 1x to the 4 minus, what's the derivative of x? 1. And then I'm going to take that equation, I'm going to set it equal to 0. Okay, remember, the name of the game is factoring for this. So how can I factor x to the 4 minus 1?
Plus 1 minus 1.
Good, perfect squares. So I'm going to take the square root of x to the 4. It's going to give me x squared. Thank you. And then the square root of 1 is going to be a +1 and a -1. Now remember, I want to break it all the way down. So this one can break down one more time. What's the square root of x squared? X, and what's the square root of 1? Plus or minus 1. So we're going to have x squared plus 1, x plus 1, x minus. Now, why can't I break down the x squared plus 1? Okay, let's just review. If I were to set this equal to 0, what would I have to do to get rid of the plus 1? I'd have to minus the 1 across. That I have x squared equals -1, and then do what? You'd have to square root on a negative. Is that allowed? No, so I'm going to put no solutions. Okay, remember, there's a reason you can only break down perfect squares with a minus in the middle. Okay, if you try to do it with a plus in the middle, you're not going to get any answers. So no answers from here. I have an x plus 1. What's my critical number? -1. And then what about from my x minus 1? That's going to give me +1. Put those on the number line. Oh, and actually, wait, sorry, we're not doing relative. We're looking for absolute. So read the next step up there at the top. So step number 1, we took the derivative, check. Step number 2, we found the critical numbers. What does step 3 say? Skip the interval test. You don't care if they're relative mins or maxes. That's not what you're looking for anyways. Go down to step 4. You're going to do what's called a candidates table. Okay, and a candidates table is really easy. All that you're going to do is make a table with the critical numbers you just found. So in this case, 1 and -1. And then also any endpoints. So if I'm only wanting absolute mins and maxes on the interval from -1 to 2, which of those numbers is new? -1 already made it into the table, but what other number? 2. So I'm going to put here, use CNs and endpoints. And then once you put those x values in a table, you're just going to see whose y value is the biggest. So my equation is f of x equals x5 minus 5x over 5. And then we're just going to take turns, plug each number in one at a time and see who's the biggest. Whoever's the biggest will be the absolute max. Whoever's the smallest will be the absolute min. So let's start with 1, because 1's easy. I'm going to do 1 to the 5th minus 5 times 1 over 5. What is 1 to any power? 1, and then 5 times 1 is 5. What's 1 minus 5? -4. And then over another 5 would be -4 over 5. So put your y value right there. Next to its partner, we plugged in 1. Now, to be a little lazy, I'm just gonna put negatives on this. Okay? So now it's not 1 to the 5th, it's -1 to the 5th. How's that gonna come out? -1. And then what happens when I do a -1 times a -5? Now it's a +5. And -1 plus 5 is gonna give me 4/5. Okay, last number that we need to plug in is our 2. So it's gonna be 2 to the 5th minus 5 times 2 over 5. Okay, 2 to the 5th, let's count them out. 2 times 2 is, times 1 more 2 is 8, times 1 more 2 is, times the last 2 is 32. And then I want 32 minus 5 times 2 would be how many? 10 over 5. 32 minus 10 is 22 over 5. And then you would simply look at your table and say, okay, well, the biggest it gets is whatever the biggest number is out of my options. Okay, and then the smallest number would be your min. So what is my absolute max? 22 over 5. Very good. So I'm going to write down here, we're not going to do this one. Okay, the absolute max is 22 over 5. And it occurs at x equals 2. What is my absolute min? My absolute min would be -4/5. And it occurs at x equals 1. Okay? But the reason you don't need a sign chart is that you don't care about the local min and max. You just care about the biggest one and the smallest one. So you're going to make a table, include the endpoints and the critical numbers, and then just observe what number came out the biggest, what number came out the smallest. Okay? All right, I think we only need to do one more, and it's going to be number 5 on the page right before. This guy right here. All right, take a look at number 5. Last question. Okay, we want to know if F is increasing or decreasing. Okay, and your relative extrema and your increasing and decreasing, those are going to be first derivative tests. Then if you'll just peek ahead to part C, what does it ask you for? Absolute extrema is where you need the candidacy chart. So if you want to just kind of mark that in, your homework is going to ask you for all 3. Yeah, I called it a okay. But you only do that if it says absolute. So let's just work through this question, then we'll be done for today. So for the equation, do you need any special rule to take the derivative of x plus 4 over x? Okay, right now we need quotient rule unless we can avoid it. Is there a way for me to get this x off the bottom so I don't have to do quotient rule? Yes, what would I do? -1. Very good. So rewrite. It's going to be x plus 4x minus 1. Now notice we haven't taken the derivative, but we're fixing our equations. We don't have to do quotient. Okay, what will the derivative be?
1 plus -1.
Okay, so x will go to a 1, and then it'll be a -4x to the what? -2. Very good. Okay, then from there, I want you to take, now that we've taken the derivative, take your x to the -2, push it back down. So your f prime of x is gonna be 1 minus 4 over x squared. And we're basically just gonna push this guy back down. Okay, in order for you to do a sign chart, you need that to be one term, not 1 minus and then a fraction. So what would I have to times the 1 by so that this can all be like one big thing instead of two separate? I want to get a common denominator. Good, and if I put an x squared on bottom, I have to also put one on top. So now my equation is x squared minus 4 over x squared. What part of that is factorable that I can break down just a little bit more? Okay, the top. X squared minus 4 is going to break down into what? X plus 2 and x minus 2. Okay, bottom is already done. Okay, let's identify your critical numbers. Remember that critical numbers, this is the first time that we have an x in the bottom. Okay, any x's in the derivative can give you critical numbers. So I have a plus 2. What is that going to give me for my first critical number? X equals -2. I also have an x minus 2. What's that going to give me? +2. And then on the bottom, I have an x on the outside of a parentheses. What number does that one give me? 0. Very good. Okay, remember, anytime that your x is just kind of like on the outside, that counts, but it's going to give you a 0. So set up your number line. 0, -2, and 2. Pick a number bigger than 2. What could we pick? Okay, 3. We could also pick 10 though, whatever number we want. Okay, so let's do 10 just since it's big. You're plugging into, be careful, this whole piece right here. So if I plug into 10 minus 2, how's it going to come out? We don't care about the number, just the sign. Positive. What about 10 plus 2? Positive. What about 10 squared? So it's plus plus divided by plus. Overall plus. Between 0 and 2, what could I pick? 1. What's 1 minus 2? -1 plus 2. 1 squared. So it was minus plus on top and a plus on bottom. Overall, what's the sign? Big negative. Between 0 and -2, what can we pick? -1. What's -1 minus 2? Negative. What's -1 plus 2? So I have a negative, positive. And then on the bottom, it's a -1 squared. Positive. How's that piece going to come out? Negative. Because remember, the negatives only cancel out in pairs. Okay, last little chunk. Smaller than -2. Let's say we pick -10. -10 minus 2 comes out. -10 plus 2. Negative. And -10 squared. Positive. So if I have a negative times a negative divided by a positive, what's the overall sign? Positive. Now remember, we're testing f prime to tell us stuff about f. When f prime is positive, which way would f be going? Uphill. Then downhill. Then more downhill. Then uphill. So the question is asking me when my graph is, let's just pick one, let's say increasing. Which intervals would I want for part A? Let's do increasing only.
-infinity to 2.
A -infinity to -2 and
2
2 to infinity. Where is it decreasing?
-2 to 0.
-2 to 2. And you can go straight through, or you could do 2 little subintervals if you want. So let's put f is increasing on -infinity to -2, union 2 to infinity. Okay, then I'm gonna put because f prime of x is greater than. All right, second part says identify your relative extrema. Remember, those are your mins and maxes, but I already did all the work. I just need to find them. Okay, what type of extrema is -2? A min, a max, or neither? -2 would be a max because it goes from uphill to downhill. What type is 0? A min, max, or neither? Okay, neither, because it goes from downhill to continuing downhill. And then what type for 2? Minimum. Very good. So we would say our graph has a relative max at x equals -2 and a relative min at x equals 2. Now, because 0 is a neither, you wouldn't have to list that. Extrema really only refers to mins and maxes. All right, last question in part C. I want the absolute extrema. Okay, then remember, we go to the candidates chart. What go in the candidates chart? What two things? Critical numbers and endpoints. Now, I'm only considering the interval from 1 to 5. So if I set up my chart with -2, 2, 1, and 5, who is going to get eliminated based on the facts they're not really in the interval? Yeah. So I'm going to put here, this is not on the interval. Okay, remember that if they give you a specific part of the number line to look at, if one of your critical numbers isn't within that, you would ignore it. Now, what are we plugging into, F or F prime? Original F. Very good. Because remember, we want to know whose Y value is the biggest and whose Y value is the smallest. So my original F of X, I'm going to write it up here, is X plus 4 over X. Let's start off by plugging in 2. So I would have 2 plus 4 over 2. What's 4 divided by 2? Add it to another 2. Y value is 4. Let's plug in 1. It's X plus 4 over X. So it's 1 plus 4 over 1. 4 divided by 1 is 4. Add it with the 1 in the front. What do I get? 5. Okay, last one here. We're plugging in a 5. So it's 5 plus 4 over 5. And I'm just going to be lazy and put 5 and 4/5. Okay, we'll just put a mixed fraction. Or if you like 5.8, that's the thing. Okay, out of those choices, who's the biggest for the absolute max? Okay, so put absolute max is 5 and 4/5. It occurs at x equals 5. Okay, but notice that the Y value is the maximum. It happens at 5, but how high it goes is this Y value here. Then what is my absolute min? Absolute min is 4 and it happens at 2. Do we see the difference? It is 4 and it happens at x equals. Feel like you can do that? There's one question on the homework I want to do together, but I'm going to give you some time to start on it on your own before we do it. So if you need paper, let me know. Yes, go ahead. Thank you for waiting. We need a little scratch. Want me to do it? Daniel? Now we need a paper. Because did Coach see by your? She responded and said, sure. Well, hold on. I don't know if she said yeah, a version of yeah. Okay. I can go back and look if you think the word matter. It does. Any paper? And then I actually got a note.
Fresh air.
Are you doing? Don't eat paper? Yes. If you wanna know which one we're gonna do together, it's third from the bottom. You what? Yeah. You already started. And then just the parking buddy. And then. Huh? With her too? Oh, yeah, just because I'm gonna forget to fix it, right, if you want it. Yeah, just email me. Alright. Okay, Lana, we taking official answer, the AP test is a yes?
Yeah.
That's okay, we have till December, I think. Aubrey, you're officially yes for AP test. You're taking it. Maybe you're yes.
Forget about the final. I'm a singer.
Parker, you're taking a yes.
Wait, is it one good drugs?
Second survey.
And I need to.
You said second, right?
Yeah. I didn't have a second.
I probably will have to already have it fixed by then, but I'm sure I'll have something for you, you know. Yeah. And then your official, and your. Yeah.
That was very cool.
You get the one that's crunchy. I think someone just.
That too.
I think someone spilled somewhere. I got that one the other day, so I was wondering why.
What's wrong, Mr. Johnson?
Right, yeah, you're an official, yes, you didn't hear the first sentence, huh?
Drink some water.
Have you emailed Miss, what's your name? Miss Clay? Yeah, you can tell her, but she might make you pay a late. You know, she said you so many. You? You're taking it?
Yeah, I love it.
She might be able to fix it. Yeah, why not, Yaya?
Yeah, sure you don't now.
Well, hey, when you email her, you.
That's why I got found it.
And if you don't take it, you know, you have to take a semester exam.
I was just, I was like.
But you have to take a final, but if you take the AP test, they count it. You have to decide like 5 days ago. But here's what I would say, if you wanna get out of it, ask her now, because if she can switch you to a no for free, like the deadline for that's probably already closed, but you can try. And then if you're gonna have to pay $40 to cancel the exam, you might as well pay $40. How are you going to about this? Yes? Oh, I see, you're already a yes, perfect. Rebecca, you're already a yes? In the fall, you have one for sure, but in the spring, and is where if you took the test, as long as you're not failing for the year, you know. For the whole year, you may not be failing for the whole year. Are you taking it? If you never, it's good. I want to look into your little beautiful eyes to confirm. Okay, and then you, are you an official yes? You just haven't paid for it yet?
Yeah.
And I just have to ask you another Daniel, are you got an answer from you? Perfect. Yes. So you forgot. It does need to be in order, but if you put parentheses, -9, -1. That makes sense. But I can, do you want me to refresh? But I'm wondering.